Alright, welcome to another video on arithmetic. So what we're going to do in this video is just go through some more exercises just to make sure that you understand all the different operations that you can perform with integers. And to start with, we're going to have this particular number here. So we have 2 raised to the power of 3 minus the square root of 16. Now we know that whenever we have something raised to a power or being operated by some kind of root, then those operations need to be performed first, and then we perform anything that has division, multiplication, or addition and subtraction. So in here what we can do is we can start by performing this operation first, followed by this one, and then we subtract those two results together. So the first one is going to be 2 to the power 3. So that is essentially the same as saying 2 times itself 3 times. So that's going to be 8. And then minus the square root of 16. So what is a number that multiplied by itself gives you 16? That's going to be 4. And then this is going to be equal to 4. For this example, we have the square root of 9 minus the cube root of 125. So for this one is what number multiplied by itself gives you 9? Well, that's going to be 3. And then for this one, what you're going to have is what number multiplied by itself 3 times is going to give you 125. So dealing with roots is a little bit tricky because there are very few numbers that actually have a root that is an integer or a whole number. So most roots are going to give you something like a number with several decimal places. In this case, what we can do is we can try and see what the multiples or what the factors of this number here are. So at first we can see that since the last digit of the number is 5, it is clearly a multiple of 5. So that's a good guess. Let's say that we multiply 5 by itself 3 times. So 5 times 5 is going to be, so let me just write it down here. 5 times 5 equals to 25, and then if we multiply 25 times 5, that is going to be 125. So that is correct. So 5 is going to be the answer here. And then 3 minus 5, that's going to come down to minus 2. For this example, we have minus 2 raised to the power of 3. Now, what is going to happen when you raise a negative number to some power is you also have to raise the negative number to that power. So what that means is that this minus sign is the same as having a minus 1 multiplying that 2 inside of the brackets. And when you have a situation like this, what you're actually going to do is you're going to raise each of those numbers individually to that power. So basically minus 2 to the power of 3 is going to break down into these two numbers. So minus 1, you know that whenever you raise 1 to any power, it's going to stay the same. But what happens when you raise minus 1 to an odd power like 3, that's going to stay negative. Because if you multiply minus 1 times itself 3 times minus 1, the first two signs are going to become positive, but then the third one is going to make it a negative again. So that means that this is going to stay as a negative number, and the 2 is going to become an 8. So that's going to be minus 8. So for the first one here, let me just erase this very quickly. The first number is going to be minus 8. And then we're going to divide that by minus 4. So we can express this as a fraction. But we notice that we are dividing a negative number by a negative number. So those two are going to become positive. So we have 8 over 4. And this is going to simplify to 2. So that's basically our answer for that question. For this one over here, we have the same situation. We're going to perform the operations on each of these roots first. And then we're going to add or subtract the results together. So here we have a cube root. What is a number that multiplied by itself is going to give you 27? So this one is a bit tricky, so we need to really think about it. Okay, it's probably going to be a small number because we already saw, okay, so 5 to the power of 3 turns out to be 125. That number is a lot larger than 27, so we should expect whatever number we choose to be a lot smaller than 5. So what are the multiples of 27 in this case? Well, remember the trick that if we add the digits together and it turns out to be a multiple of 3, then that number must be divisible by 3. So in this case, if we add 2 plus 7, that becomes 9, which is a multiple of 3, which means that we can divide this by 3. So let's start by just guessing that if we multiply 3 by itself 3 times, that's going to give us 27. So the first two are going to give us 9, and then multiplied by another 3, that's going to be 27. So indeed, this is going to be 3. Square root of 9, we already found it in this example, is just going to be 3. And then we have the cube root of 1. Well, that's just going to be 1, because 1 multiplied by itself 3 times is 1. Now these two are going to cancel out, because 3 minus 3 is 0, and then we have minus 1, so this is going to be minus 1. For this one, we're going to do the same, but now we're going to raise them to different powers. So 1 to the power 3 is 1, plus 2 to the power 3 is 8, minus. Okay, so here we have to be very careful. Minus 3 to the power 3 is not the same as saying minus 3 raised to the power of 3. It's a very different operation. So this minus sign is not actually part of the exponent operation that we have here. It is outside. So you need to raise this to the power 3 first, and then you multiply it by the minus 1. So this is going to be minus 3 to the power 3, we already found is 27. So this plus that is 9, minus 27. Now this is going to be minus 18. So be very careful with this kind of thing, because a lot of people make mistakes with this. And basically, if the negative sign is not inside a bracket with the 3, then it is not being raised to the same power. And then for the final one, we have this situation here. This looks a little bit complicated, but it's actually quite simple when you realize, well, we know that when we raise 1 to any power, it's just going to stay the same. In this case, we have minus 1, and we know, okay, so minus 1 raised to an even power is always going to be positive, because minus times minus is positive. And then if you have something like minus 1 to the power 4, that's this twice over, so that's still going to be positive, and so on. But if you raise it to an odd power, that's going to be negative. So in this case, 101 is an odd number, so that means this is going to stay as minus 1. This one over here is raised to an even power, so this one is going to be positive 1. And then this one over here, we have the cube root of minus 1. And if we think about it, if we multiply minus 1 by itself 3 times, that remains as minus 1. So now what is happening here is we have minus 1 times 1, that's still minus 1, and then times minus 1. These two negative signs are going to become positive. So in the end, this is going to be equal to just 1. Now for the next set of exercises, we're just going to substitute some numbers into these expressions and then evaluate what results from them. So for the first one, for example, we're going to plug minus 2 into a here. So that means that we're going to take the entire number, minus 2, and put it inside brackets and raise it to the power of 2. And then minus b, that's going to be 6. So this one is negative raised to an even power, that's going to become positive. And then 2 to the power of 2, that's 4. So 4 minus 6 equals to minus 2. For this one, we have 3b plus ac. So let's do that. So 3 times 6. Now look at how I'm writing this. I'm not writing the cross in between. I'm just writing it as 3 bracket 6, which means 3 times 6. And then here I'm going to have a times c. So we're going to have minus 2 times minus 3. So 3 times 6 is 18. And then we have minus times minus, that's going to become a positive number. And 2 times 3 is 6. So this is plus 6. And this is going to be 24. Now we have 2c plus a, so that's going to be 2 times minus 3 plus minus 2. So this is going to become minus 6. This is going to stay as minus 2. And minus 6 minus 2, that's minus 8. B squared minus c squared, that's going to be 6 raised to the power of 2 minus minus 3 raised to the power of 2. So 6 to the power of 2, that's going to be 6 times 6, that's 36. And then minus whatever results from this operation. So raising this to an even power, that's going to result in a positive number. And 3 squared is just going to be 9. So now we have this negative sign, which means 36 minus 9 is going to be 27. Now let's do this one. So we have a, which is minus 2, times 6 times minus 3, minus a times c. So that's going to be minus 2 times minus 3. I'm just going to write the cross here so it makes it a little bit clearer what's happening here. And then that's raised to the power of 2. Okay, so let's start with this one. What do we notice about this number? Well, we have two negative signs involving here. They're multiplying each other, so they're going to result in a positive number. So negative times negative, that's going to become a positive number. And we have 2 times 6, which is 12, times 3, which is 36. Minus. So here what we need to do first is we need to multiply the inside of the bracket first. So minus 2 times minus 3, that's going to become positive, so that's going to be plus 6. And now we're going to square that. So 36 minus 6 squared, which is 36 again, it's going to be 0. And the final one is just going to be minus 2 minus 6 squared. So minus 2 minus 36. And that's minus 38. So hopefully these exercises have given you an idea of how you need to do all those different types of operations and why it is important to have brackets in the right places so that whenever you're reading this kind of operation, you actually know what's happening and what operation should come first. And the same applies for this kind of substitutions that you do. So this is something that we'll do quite a lot in algebra when we start that topic. And it is important to always know that you need to include brackets because otherwise things will get very, very confusing for you and for anyone who is reading your work. So make sure you include brackets in all the right places.